First, we'll include the viewport for the mobile devices. This tag will ensure that our HTML content will be displayed properly in mobile devices without the need of additional zooming from the user. Then we'll type links to our CSS files. First, we use reset CSS. It's a default template CSS file which fixes some inconsistencies which happen between different browsers, especially while setting margins and paddings. This is just to our content to be displayed equally in different browsers. Then we include our actual CSS and we put everything into the head section. Then we start with the body tag and we save the file as index.html. If we open this file in our browser, we see that there will be nothing inside. But now we'll start coding little by little our to-do list. We'll have some HTML5 elements, the header, and inside we'll have the input box. Within the placeholder, we'll type enter activity and we'll give an ID of item in order later this input to be used by our JavaScript. Then we'll type the button next to it and we'll give a plus sign. If we save and refresh the browser, we see that we have enter activity and one plus sign button, which at this point does nothing. So we start doing our lists. We'll put them in one container. We'll have two UL elements. The first one will have the items which need to be done, and the second one will contain the finished or completed items. The first one and the second one will have an ID of completed. We'll close our container and we'll include our JavaScript at the end. Save and refresh. So far we don't see anything different, but if we inspect the elements, we see that we have the header element, the input inside, and the button, as well as the container with the two lists inside, which are not visible. Now let's create our style CSS and colorize those inputs. Right, so we create one file called style.css and let's first style the body. We'll give a background and we'll center the content within a certain width. If we go back to the browser and refresh, we see that our content is centered across the screen. Next, let's style the header. We'll give a little padding of the elements and a little box shadow. Now the header is having more space from the top. Also, we'll give background color to the header and the header is okay. Then let's style the input which resides on the header. We'll change its color. We'll have a little bit of space in front of the text, so it will be like this on size. We'll give a little padding and we'll give a little bit of transparency on the background. As well, we'll give some border radius. We'll remove the border from the element. We'll give some height, so the element will be much bigger in size, and a width. So we'll make the element to span the whole width of the container. Let's refresh. And now this is our styled input element. Let's place this plus sign on the right side. This will be done using the tag header button. Again, we'll give a border radius, a background. We'll remove the border of the button, height and width. And we will like the user, when it clicks on the button, to show a hand, type cursor pointer. When we refresh, we have the element here. So we would like to move it on the right side. This can be done if we subtract from its margin left, the subtraction like this, and the button comes into its place. So let's continue writing our HTML code. And this time we'll place one item inside of our to-do list, just to take a look how it will look like, and we'll style it. So first we'll type one UI tag within our to-do list, and inside we'll type text, and then we'll add two buttons inside one div. We'll give to the buttons class complete, and to the other will be class remove. Then we'll type a special symbols inside of them, which are called HTML entities, and they can display useful characters for our application. Let's save and refresh, and we see our first item hello and the two buttons with their respectful symbols inside. If we take a look at the element and we open the first UL tag, inside we have those Y items and the buttons inside of div class of buttons. Now it's time to style those buttons. We go back to our style CSS and we'll create new rules for them. Since they reside in the class of buttons, first off, we would like to float them a little bit to the right. So if we save, we'll see that they are occupying the right space of the item. Then let's style the inside buttons. So we'll type a cursor of pointer in order to have our hand displayed when the user reaches them. We'll give a border, which will be hidden for now, and we'll align them in the middle. Also, we will give a width and height, and we'll give a transition of the buttons because we would like them to change colors and this to be happening smoothly. This way, when the user hovers the buttons, it will wait 0.2 seconds before changing the state, and it will be much more smooth, the visual effect. And now we'll type those hover states of the buttons. So it will be buttons, button with the class complete. When the user places its mouse on it, we'll change the background to white and the initial background of the button. And we are filling the initial border of the button. So we place 0.1 rem border for the button. We save and test. And this is our state of the buttons right now. We continue with the remove button. We change its background color. And when the user hovers the button or place its mouse above it, we'll change its background. Let's see. Our buttons are styled correctly. Now let's style the whole UI item. We'll change color, text inside. They'll be white and will be rounded. We'll give again box shadow to them with little transparency. We separate them one from another with margin property. We'll give padding to the elements inside, and we'll make sure when we enter text, it will wrap around and not fill the whole space. This way will be more eye-pleasing and not breaking the layout we are creating. Let's test. And this is our initial element. When we place reset.css, it will remove this initial dot from the UI element. We'll just create a new file and place the content of the minified version of the reset file and save it as a reset.min.css. It's included within our index file. So when we refresh our code, we see that the element is placed correctly on the viewport. Let's create similar element within the second list. We see that there is a space between them, but we will also like, if there is nothing inside one of the lists, something to be displayed to the user. We can use very interesting CSS technique for this. So we have the two lists, and we can place at the end of the lists text using the after CSS selector. It will be triggered only when the list is empty. So we can write those selectors right now and test them when we delete the information from the first or the second list. First, we'll write the text we would like to display. So if our to-do list is empty, we would like after it to append a content, which will be nothing to do. The same we'll do with our completed list. This time we'll write you can complete or add new tasks. To test this functionality, we'll go back to our index.html file and make sure that you've selected all inside the UL tag and delete it. First, we'll remove the to-do items. We save and refresh, and we see nothing to do. And if we do the same for the completed items and we delete and save, we see that you can complete or add new tasks displayed on the screen. Now we can style a little bit further those elements. For example, we can center them and change their color. And let's test again. We have those notifications displayed centered on the screen. Now to finish the styling, we would like our already done tasks, like this one, it's ready to be somehow distinguished from the task we are already doing. For this, we'll change their background color and we'll give a opacity of 0.5, so they'll be semi-transparent. If we refresh, we see that this effect is achieved. First, we'll set up our working file and we'll place all the code inside one function. This function will be like a wrapper to our code, and in order not other scripts which may reside on your website to be affected by our, and also we'll execute the function. So whatever we will type here, for example, we'll write something to the console and we save and refresh our browser. We receive our hello here. The next thing we would like to do is to grab the main elements of our user interface and to have them saved as local variables. We'll grab the to-do list. Those are all the elements with the ID of to-do. We'll grab the completed list. We also grab what's inside of this HTML input element, and we call it item. And also we will need to get a reference to this button. So we'll get it like this. And then we'll attach an event listener to it. So the moment someone clicks on it, we'll respond in some way. We'll start a function called addItem, and let's see if we write this function further below how it will work. We'll just type to the console, click. When we save, let's refresh the code. When we click on the button, we see that clicked is displayed. Next, we would like to capture user input. So as long as we are typing here something, we would like when we press enter, the same function to be triggered as when we pressed on the button. Let's see how we can do this. We'll attach an event listener this time to our input. So item at event listener. And the moment someone types something, we'll start a function. We'll grab the event inside the function and we'll check if the user has pressed enter. Then we'll start our addItem function. So we'll check the code of the event. If it's enter, we'll start our function addItem. All right, so we can test our code. We refresh the browser, we type something, and we press enter. And we see that the function addItem is clicked. How can we get what the user is typing? Well, we just have to get the value of the input element. And since this is our input, we'll just display it on the console. And when we refresh, the moment we type something and press enter, we see that we are grabbing the input from the input element. And for now, we'll leave the function like this. Inside of this function, we'll need to make a little check. If we don't have anything in our input box, we'll just return. So the code below will not be triggered. If we test our code with nothing inside, we see that although pressing on the buttons, we don't see this function triggered. So our check is working correctly. Now we need to know where to store our elements. It's good to save our data within a structure, which will be saved then in our local storage. So the data we would like to save will be an array. It will be called items. And inside of this array, we'll have objects, which will be our user entered data. At first, this array will be empty, and then we would like to save it into a variable called data. So this is our storage for now. And if you would like to put it in the local storage, we'll just type local storage.setItem, and let's call it todo-list. And then we'll use the data from our variable here. So you just type data, but it's good to represent this data as a JSON string. So we'll use JSON stringify on this data. If we save and refresh our browser and head up to our application tab, we'll see that under local storage, we already have a key called todo-list and we saved our items in there. We would like to save the data into local storage using a special function, which will be called only when we need to save the data there. So we'll wrap this line into a function. We'll call it update local storage. And now let's think how to get the items out of the local storage. This can be done using the function getItem, local storage.getItem. Our local storage key is todo-list, and we will save it into our data variable. Let's say that we would like to check if there is something in the local storage. So the data could be equal to this to-do list if there is data. And if there is data, we will just grab it using the JSON parse and we will decode what's inside the local storage. And if not, we will just construct an empty list like before. So this way, we are checking if there is something in our local storage. And if there is, we decode the data inside. If there is nothing, we just construct an empty array which will be filled later with objects. Inside of this data variable, we have items, and we can add something into those items using data.items.push, let's say new information, and we can display it on the console what's going on inside the items array. We see that we have new information. If we push more variables inside and refresh, we see that the array contains 2 objects. If now we update our local storage using the update local storage function, when we refresh and we go to the application, we see our items saved into our to-do list, and this is all in the local storage. Now we don't need to push anything into the local storage, and let's say the user refreshes the screen and we just want to print what's inside data items on the console. We see the information is persistent because we are fetching it from the local storage. If there is no information in the local storage, we are starting with empty array of items. Let's continue with our function addItem. We'll expand it a little bit. So all this information about a certain item, we'll create a structure and we'll place it inside. Let's create this structure. I will call it current item. It will have those fields ID, value, and completed. Let's type for the beginning, the item is not completed. So whenever user enters something, it will be fresh and needs to be done. For the value, we'll grab what we have inside of our input box. So it will be item.value. And for the ID, we'll just type some random mathematical number. Okay, we have our current item. It has those properties. So we have this object. And now we would like to push it into our data structure because this data structure holds this items array full of those objects. So we will just use data.items.push and we'll push the current item. And the next thing we would like to do is just to clear what we have inside of our input box. So it will be just item.value equals to empty string. And let's test this function. If we refresh the browser and write something, and click on the plus, this will trigger the addItem function. Let's test what we'll have inside of our data items. Let's write something. And in the console, we have already appended a third element, which is having an ID, a random value. This is this ID here. The value is taken from the input box and a status of completed or false. So we have the data items. Next thing is to put them in the local storage. We'll just trigger the function update local storage. And if we check now, our local storage still has the old information. But when we refresh and type something here, we see that the local storage is getting expanded and we have a new object inside. Now let's get this information and expand this list that we are having. So far, this list is static. So let's grab the information we are typing and create a new item and add it to our UL list. We would like to trigger a new function, which we'll call attachToDOM, because we are attaching the elements to the document object model, and we'll attach the current item there. And now we'll make this function. It will accept the data as a parameter. First, we need to decide where to place a new item, whether it will be in the upper list or in the lower one. So in order to decide, we'll create a little if statement, and it will be based on the data.completed property. So if the data completed is true, we'll add it to the completed list. Otherwise, we'll add it to the to-do list, and we'll save this into a variable called placeholder. Then the next thing is just to fill the placeholder inner property with our data. In order to do this, we'll use a special function, which will be like a template function, and we'll call it render. So notice one more thing, we are not overwriting the whole placeholder element. So we are not overwriting the previous elements inside, but we're using the append operation. So before the equal sign, we have a plus sign. This way we can add more elements without overwriting the existing ones. And now let's write this template render function. It will just return a simple HTML string filled with data. And we can grab all this data from within our HTML. So we'll just grab what we've written here and type it in our JavaScript. So you can use also those literals, which will make writing HTML very easy inside of JavaScript. And here we would like to place the data value. So we are grabbing something from the data and we're displaying its value property. Let's save and refresh. And the moment we type something, we see that it appears as an element into our already created list. Now we go back and delete everything we created as a static HTML and refresh. We see that we don't have anything in our lists. Let's see how we can propagate this information back to the screen. We go to the beginning and we will loop through all the items already saved in our local storage and display them using attachToDOM function. So first we check if there is something in the data items. So if we have something in our structure here, data items, and if we have, we create one loop. This loop goes through the end of all the items which means that if we have 5 items, it will go from 0 to 4. And for each of the items, we will attach to the document object model. We'll just place data items and the current item we grab from this for cycle. So we are attached to the DOM, the 0 element, the first, etc., until we finish with this data items list. We save and refresh, and we see that our items in the local storage have appeared. So let's clean up our local storage contents at a refresh and write something new. Okay, we have it. Let's now make the functionality of the buttons. For the big lists, we attach event listeners on click, and we run function button click. This is for the to-do list. Now we will make the same for the completed list. And now let's write what will be inside of our button click function. First, we would like to grab the event. We would like to inspect, and it will have a target. So we'll save the target into a variable, and we will check if the user has clicked anywhere else or the event target element is not a button. We'll just return from this function. Else we'll just write something to the console, like clicked on button. Let's test when we click somewhere else. Although the event handler is handling the whole URL element, it's not responding. When we click on the button, it displays clicked on a button. Let's think on how to distinguish between different elements. Let's say that we have a second one, and we would like to distinguish between those two. There are several methods available. We'll suggest to add an item ID to the list element. So we already have this ID here. So exactly this ID we are saving into our local storage. Yeah, they have ID. And with this ID, we'll just place it as a new variable data ID in our LI in order to distinguish which element we are working on. In order to accomplish this, first we need to change our render template. So inside of the LI tag, we'll add data.id. When we save, refresh, and inspect those elements, we see that we have data ID here for the first list item, and the second list item has a different data ID. So we go back to our button function, and we would like from those buttons to reach the LI element, which means that we are inside here. As you can see, we have buttons, and we are inside of one of those buttons. We would like to reach their parent element, then we would like to reach the parent element of the buttons class. So our LI is actually our target element, so the button, but from the button we return to the parent node and then again to its parent node, and we can get the data ID of this element. If we refresh and go to the console and click on some of the elements, we know that we are clicking on the element with ID 5 and here with ID 94. Once we have the ID of the element, we would like to parse it as an integer. So we create a local variable and just use the parseInt function of the same element. We do this because otherwise the attribute will be a string, and for later we'll need to use it as an integer. Then we would like to grab the class name of those elements, so to know whether we are clicking on the delete or the complete button, and we make a check. If their class names are remove, we'll just log removing item. And the same check we are doing for the complete button, we'll type completing item. So if we refresh, we see that we are removing, completing, so the buttons are working correctly. When clicking on one of those buttons, we are just moving the element from one list to another. And visually, this can be done by just removing this element and recreating it and appending to another list. So we'll just remove the LI element. For this, we will need the parent element of the LI tag, and we will type LI parent node. So for now, if we click on any of those buttons, they'll be removed from the screen. Now, let's write functions that will work on removing the items and completing the items. For them, we will need the data ID, and now we can write those functions. First, the removeItem. We'll have a special variable called search inside, and this removeItem will just run a function which will filter all the elements within our data array, and will return only those which are not equal to our searched element. This way, it will effectively remove our item from the data array. We'll use data.items filter, and for each element of this array, we'll just return all those elements which are not equal to our search element. This array will just save in our data items. And let's not forget to update our local storage in order for those changes into the data array to happen in the local storage also. When we remove an element, it disappears from the screen as well as from our local storage. Now let's call the complete button. We'll type function complete item, and inside we'll loop manually through all the data we have already accumulated in our data.items, and we'll check if our IDs are the same as what we are searching for, the IDs of the current element we are looping. This way we'll be on the element we would like to change its status to complete. So we will do this, data items completed equals, let's say, true. But we would like to reuse this function, not only for completed items, but for all kinds of items. So we change its name to updateItem as well here. And we'll just set it to the opposite of what it was before. So if it was true, we'll set it to false and vice versa. Of course, we have to compare the appropriate index of those items. Let's save and refresh and click on complete. We see that the completed is true. And now this is in our second list. And the next thing we would like to do is to attach this element to the appropriate list. For this, we'll use the attachToDOM function, and we'll just attach the current element. And we will stop the loop with break. And when we save and refresh, let's test the update. Okay, guys, let's see how we can actually optimize our application. And on the left side, we have its optimized version. On the right side is as is from our tutorial. So what can we see? In the first place, we have a lot of replacements of var with const, and this is for memory optimization and also a way to show immutability of the data. So after placing const, for example, in front of to-do-list key, we cannot change afterwards the data that this variable is pointing to. Other cosmetic change is that we're using camel case instead of underscore and a small letter. This is another naming convention. And of course, replacement of double quotes with single quotes. Now let's go to the more important optimizations. For example, in the optimized version, we're checking whether we'll get something from local storage. And if not, using the OR operator, we'll construct one object with an empty array inside. Also on line 22 and 23, we see that the for cycle with its long syntax is being replaced with for each. So basically it will loop through all the items and it will run for each of the items attachToDOM function. The same thing that we are doing with a little bit longer syntax on the right. There are also interesting logical optimizations. Instead of using parent node on the right side, now we can use the closest function that will find the closest AI element next to our target element. This will help us because our initial solution was relying on hard-coded HTML structure. Now we can have more flexible structure and closest will go and find our AI element easily. Also, on the left, we are using class list and it contains function instead of relying of class name search with manual equal operator. Again, here for better usability and refactoring later, we are using instead of parent node remove child, just the remove function on the AI element. Next, instead of using the function word and the return statement, we can wrap all this functionality into one single line together with an arrow function. In the updateItem function, we see that this whole for loop is replaced with find index function that will help us to find the index of the element that we need. And then if we have results, we'll do our update and we'll attach to the DOM the updated data. Another performance optimization we can see in the function attachToDOM. In the earliest release, we are using the plus and equal duration to add elements to the DOM, which will cause some performance degradation. And in the optimized version, we are saving the rendered data into one HTML variable. And afterwards, using the insert adjacent HTML, we are inserting this rendered data into our placeholder. Okay, guys, I hope you enjoyed this information, and please don't forget to subscribe to the channel if you find it useful. Thank you.